This is our example 3, which is saying that a plane mirror is placed at a distance d from a convex mirror of focal length f, such that it covers about half of the mirror surface. A pin is placed at a distance L in front of the plane mirror, giving an image in it which coincides with that of the pin in the convex mirror. The same with the aid of a diagram or illustration, you should show that this expression is very right. So, the saying use an illustration. If I'm to use my illustration, I would draw that to act as my principal axis, and then I assume this is my convex mirror, and then here this is my plane mirror. Okay? They're saying that the plane mirror is placed at a distance d from the convex. That means that from the convex mirror, this is my convex mirror, and this is the plane mirror. So it is placed at a distance d, okay, from the convex mirror. Of focal length, here we have focal length F0, covering a half like I've drawn. Half should be covered, half should be left of the mirror surface. A pin is placed at a distance L in front of plane mirror. From the plane mirror, they placed a pin that I would say is maybe here. This is now my pin. I would say my pin is this. That is my pin. So, if that is my pin, I'm going to say that it is placed at a distance L in front of the plane mirror. From the plane mirror up to where the pin is, the distance, they are calling it L. Okay? And now they are saying that in front of the plane mirror, it gives an image which coincides. The image of this pin here, it will come this other side here. Okay? If the pin is here, it will form the image here. But now this image here will basically be at a distance for plane mirror. If this is L, this would also be L. Okay? And then it will also form. All these images are virtual. They are virtual images. They are virtual images. If it is coinciding, that means that if the plane mirror forms it here, even the convex mirror will form it here. And as we have been saying, this one therefore will act as our U, and this one will act as our V. Okay? So required from us is now to prove that idea there. And then I can say action of the convex mirror. So U for the convex mirror will be L plus D, and the V will be L minus D but a negative. Okay? It is the L subtract away that will be that. And then I can say using 1 out of F equaling to 1 out of U plus 1 out of V. Okay? I'll therefore say 1 out of F equaling to 1 out of U, which is L plus D. Okay? And then because here is going to be a minus, I can now just put it here directly and say this is L minus D. This negative here has now come here. So from here, my LCM will be L plus D, and then L minus D equal to 1 out of F. So if LCM is that, I'll say this divided by that, you will get L minus D. Okay? And then minus this divided by that will be L plus D. Okay? Then we hope we are still following. We are now going to say my 1 out of F4 my 1 out of F is equivalent to, this is L minus D minus L minus D out of difference of two squares, we shall say L squared minus D squared. And my 1 out of F is equivalent to, this will excuse us, it will become negative 2D out of L squared minus D squared. That is 1 out of F. This negative here, I can now say this is 2D out of, to remove the negative, I can multiply by negative 1 by negative 1. Such that this one becomes now D squared minus L squared. To remove the negative away. So, if I decide now to cross multiply, I will say this is now taking me to 2FD equaling to D squared minus L squared. And this is what they wanted you to prove in this example of ours. So, thanks for listening. Let's now meet in the next episode.